Yeah, welcome to BOOKiT Academy. So today we are going to be talking about the L'Hopital's rule. Now the question is, why do we need the L'Hopital's rule? We need the L'Hopital's rule whenever we want to find for the limits of a function such that by substitution we see that that rational function or the quotient function results to an indeterminate value or an undefined result. So for example, this is how we make use of the L'Hopital's rule. So for example, let us look at a function such that we have the limit of the function as x tends to minus 1 of 2x raised to the power of 2 minus 2 all over x raised to the power of 2 minus 1. Let us look at this simple function. Now, we want to find the limit of this function. To get the limit of this function, we just have to directly substitute minus 1 into this value, into this function that you have here. That wherever you see x, replace it with minus 1. So let us do that. So we have this to be equal to 2 open bracket minus 1 raised to the power of 2 minus 2 all over, this is x squared, so we have this to be minus 1 raised to the power of 2 minus 1. So that this is going to be equal to, evaluating the numerator and the denominator, minus 1 to the power of 2 is going to give us 1 times 2 minus 2. This is going to give us 0 all over minus 1 to the power of 2, 1 minus 1, that is going to give us 0. But what kind of mathematics, what kind of calculation gives you a result that is 0 over 0, such that we have a 0 at the denominator? How do you evaluate this? This is what is referred to as an indeterminate result or an undefined result that does not have a measurable value. So this implies that the limit of this function does not exist. But it is not true. According to L'Hopital stated that whenever we are working with the limit of a quotient function such that it is indeterminate, what we do is that we have to simply differentiate each of the terms in the given function just the way they are. So let us do that now. So we want to apply the L'Hopital's rule. So how do we apply the L'Hopital's rule? Alternatively, we can go on to say, according to the L'Hopital's rule, we have the limit as x approaches minus 1 of 2x raised to the power of 2 minus 2 all over x raised to the power of 2 minus 1. Now, L'Hopital says, let us differentiate each of the terms just the way they are to get the limit of this function. So we have this to be the limit as x approaches minus 1 of, if we differentiate to x squared, applying the power rule, we have that to be given by 4x. Minus 2, when we differentiate minus 2, that is going to give us 0 all over x squared. When it is differentiated, we have that to be 2x. And minus 1, when we differentiate minus 1, we have that to be 0. So it implies that this is what we are having. So our result has now been reduced to something that we can carry out substitution for. So with this now, we have this to be equal to the limit of this function, which is also equal to this, is going to be given by 4 open brackets as x approaches minus 1. We have that to be minus 1 all over 2 open bracket minus 1. And this is going to give us the value of 2. So the limit of this function as x approaches minus 1 is equal to 2. So the L'Hopital's allows us to be able to find for the limit of a function, of a rational function, given that the direct substitution does not work. So let us look at this example now. Let us look at the first example. It says, find the limit of the function f of x, which is equal to that as x approaches 2. Solution. Solution. Now, we want to find for the limit of this function, the limit of f of x as x approaches 2. That is how we write that. This is equal to the limit of the function as x approaches 2 of our f of x is given by this quotient or rational algebraic function that we have here, and this is given by x raised to the power of 2 plus 4x minus 12 all over x raised to the power of 2 minus 2x. So now this is what we want to do now. So let us check if direct substitution will give us the limit of the function. So by direct substitution, this implies that this is going to be given by as x approaches 2. Wherever we see x in the function, replace it with 2. So this is going to give us 2 raised to the power of 2 plus 4 times 2 minus 12 all over the denominator is 2 raised to the power of 2 minus 2 times 2. And this is going to give us 2 raised to the power of 2 is 4 plus 4 times 2 is 8. 8 plus 4, that is going to give us 12. 12 minus 12, that's going to give us 0. All over 2 raised to the power of 2 is going to give us 4. Minus 2 times 2, that is going to give us 4. So 4 minus 4, that gives us 0. So we have this to be given by 0. So what do we have here? We have given us 0 all over 0. So what we have here is that by direct substitution, we find that the value, the limit of the function is indeterminate. It is undefined. So this is where L'Hopital's rule becomes very, very important in finding the limit of the function. So what do we do now? We can go on to say, applying the limit of the function, applying the L'Hopital's rule, what do? We have that the limit of the function as x tends to 2 of, open bracket, x raised to the power of 2 plus 4x minus 12 all over x raised to the power of 2 minus 2x. This is equal to, applying the L'Hopital's rule demands that we have to differentiate each of the function just the way they are, just the way they appear. So by differentiation, we have this to be the limits as x approaches 2 of, in this case, if you differentiate x raised to the power of 2, once more applying the power rule to each and every terms in the function, we have this to be given by 2x plus 4x differentiated is going to give us plus 4 minus 12 is a constant. When you differentiate it, that's going to give us 0 all over x raised to the power of 2. When we differentiate it, we have that to be 2x and minus 2x. When you differentiate, that should give us minus 2. So this is the limit. This is the redefined limit of the function applying the L'Hopital's rule. So we can now carry out direct substitution. So let us see if by direct substitution with the redefined function, it is going to give us an actual limit. So with this now, we have this to be equal to, this should be equal to. Now, the limit of the function as x tends to 2 requires that we should directly substitute the x into this function wherever x appears. So with this, we have 2 times 2 plus 4, the constant, all over this. We have this to be given by 2 times 2 minus 2 minus 2. And this should be equal to 2 times 2, that is going to give us 4 plus 4 all over 2 times 2, that is going to give us 4 minus 2. So we have that to be equal to 8 all over 4 minus 2. We have that to be given by 2. So with this now, the limit of the function as x approaches 2 is given by 2. So this is how we can apply the L'Hopital's rule to any given function where the quotient function by direct substitution leads to a result that is undefined. So thank you very much for watching, and please endeavor to subscribe to this channel and also drop your comments and we will attend to each and every one of them. Thank you very much.